Now see here, in optical instruments, we have classification, microscopes and telescopes. In microscope, we have simple microscope, compound microscope. In telescopes, we have two types of telescope. One is terrestrial telescope. Terrestrial telescope, and the second one is what? Astronomical telescope. Okay. In terrestrial telescope, we have refracting telescope. Okay. Refracting telescope. And the second one, astronomical, we have two. Okay, there are two in astronomical. One is reflecting, and the second one is refracting. And the second one is refracting. Okay, so this is the classification. Okay, it's okay. Anyways, I'm recording the meeting. I'll once the class is over, then I will upload the videos. Okay. Now, optical instruments, we have classification, microscope and telescope. First, we'll start with simple micro. We have classification, simple microscope, compound microscope. When I say simple microscope, it is normal magnifying glass. Compound microscope means what? In bio lab we have this compound microscope. Coming to terrestrial, see, terrestrial means which we use on the land. I want to see something very far, like doorbin, or I say binocular. That is a terrestrial telescope. Means the image is as it is. Means it is not upside down. It is erect. Whereas in astronomical telescope, the image is upside down. It is inverted image. So in that we have two. One is reflecting, the other is refracting. But in our syllabus, we don't have refracting. Okay, so don't get confused with this one. So we have only reflecting, astronomical, terrestrial, refracting, simple, and compound. Only these four are there in our syllabus. And now coming to the derivation, we have figures for everyone: simple, compound, terrestrial, refracting, astronomical, reflecting. We have diagrams, and also we have derivation only for these two. We don't have derivations for these two, remaining two. Is that clear? We don't have derivation for the other one.
Yes, sir.
So I'm starting with the first derivation. Starting with the first derivation, that is simple microscope. Okay, starting with simple microscope. So to make you understand about the simple microscope, we have to understand first grade 10 length. There are six figures of grade 10, of convex lens. Can I erase this now?
Yes, sir.
Terrestrial only refracting. Refracting means only we have lenses. Reflecting means mirrors. Keep that in the mind. Refracting means lenses. Reflecting means we have only mirrors. Okay, concave or convex mirrors, such type of things we use. Now, going ahead. Okay, so see, once I complete this today, I will try to finish off. It will be like 2 hours class. Okay, 1 second. I'll just. So okay, so I'll try to finish up these two lessons. I'm sorry, these two the telescopes and microscopes today. I'll try to finish up. After that, tomorrow I will take numericals of this lesson. See, the lengthy chapter and which carry more marks is ray optics and wave optics. And you can expect a case study also from here. 1 5-marker and 1 case study. And 1 3-marker also. 3-marker mostly a telescope or microscope, definitely, no doubt about it. Or prism thing, definitely one will be. Telescope or microscope, there is a short question, no doubt about it. And from prism and the refracting surface and all, that also 1 3-marker you can expect. So these two lessons and the electromagnetic waves carry around 17 marks. So please be sure with this lesson. Now, starting with the microscope first. Simple microscope. Starting with simple microscope. So I'm taking here a convex lens. This is a convex lens. Now, this is an object. Okay, there is an object here like this. So we array which is parallel to principal axis after refraction passes through the focal point. And the second one, array which passes through optic center goes undeviated. Okay. Array which goes from optic center goes undeviated. So this is the object. Okay. So here we have U is the object distance and D is least distance of distinct vision. What is the meaning of D, least distance of distinct vision? Any idea? Least distance of distinct vision.
Sir, is this a focal point?
No, least distance of distinct vision means the distance from the eye to the object where you can see the object very clearly. The distance from the object from the eye to the object where we can see the object very clearly. That is known as least distance of distinct vision, which is equal to approximately 25 centimeters. Okay. Now we have a near point also. What is the meaning of near point? Near point. Near point is 8 centimeter. Means even if you keep an object very close to your eye like this, then also you can see the object, but it is painful on the eye. It is painful. So that is near point. Next is what? Power of accommodation. All these are deleted, but but they are using this least distance. Sometimes they will use this in the terms in the numericals also. Only for that reason I'm discussing this. So power of accommodation. What is the meaning of this? Power of accommodation. Can you tell me what is the meaning of this? Power of accommodation means, see what happens is, I am looking at the object like this. The focal length of my eye, there is a small lens in our eye. That focal length is adjusted to this point now. Means the lens became like this, thick. And the focal length is very small. Now immediately I focus at a building very far from me. Okay, then what happens? My eye lens, the focal length will become very thin. So this is the gift, okay, gift from God. So what we say, like it gets automatically adjusted. But in the cameras, old cameras, like nowadays, slowly it is getting adjusted, digital ones. But the old, we have to manually DSLR for DSLR cameras, we have to manually focus, right? Front, that is near object and far object, manually we have to do that. Okay, so in power of accommodation, what is happening? Our eye, the lens in our eye is the focal length of the lens which is present in our eye is getting adjusted, okay, automatically because of the distances closer or farther. So this phenomena is known as power of accommodation. Is that clear? And there is one more concept called the pupil. The pupil in the eye, what happens is when the room is very dark, what happens? The pupil will become large and it will allow most of the light to enter through this pupil. But suddenly when the light comes, then what will happen? We will close our eye for a fraction of a moment. Why? Because most of the light is entering through the eye and it hurts the eye. So for that reason, we close the eye for a moment. And what happens? The pupil will become reduced. The size of the pupil will reduce, or the radius of the pupil will reduce, and it will allow enough amount of light through that. Is that clear? So these are the four situations. Okay. Now I'm going back to the diagram again. So in the diagram we have U is the object, U is the object distance, and D is the least distance of distinct vision. And is it a real image or virtual image? This image, is it a real or virtual?
Virtual.
Virtual image. Very good. It's a virtual image from behind the mirror. Okay. And please draw the arrows. If you don't draw the arrows, CBSE people will cut the marks. Okay. Next, here you have to draw the eye also, please. Okay. Draw a beautiful eye also here. Okay, eye like this. So that completes your figure. And I focused it on near point. I focused on near point. I focused on near point. Okay. So this is about the formula. Now we'll start with magnification. What is magnification? Image distance upon object distance. Magnification is image distance upon object distance. What is the formula for focal length? 1 by f is for the lens. 1 by f is equal to 1 by v minus 1 by u. Now we will simplify this one. We will simplify that. 1 by u is equal to what? 1 by V minus 1 by F. Okay, 1 by V minus 1 by F. Okay, so here I will substitute in the place of 1 by U, I will substitute the whole thing. So what will happen? M equal to what? V into 1 by V minus 1 by F. So M equal to what? V by V minus V by F. This and this will go away. M is equal to what? 1 minus V by F. Okay, 1 minus V by F. So here, what is V? V is minus D. Is that clear? As per the sign convention, V is equal to minus D. So the formula is what? M is equal to what? M is equal to 1 minus D by F. 1 plus D by F. Is that clear? This is the first formula. Means when the image is formed at the least distance of distinct vision, then the formula for magnification is 1 plus D by F. Is that clear? See once again, this is the, okay, let me finish off the second part also, then I will explain once again. Or see here, this is the lens, this is the object whose height, object distance is U, image distance is V, and the object is placed somewhere between the focal point and the optic center. Then the image is formed behind the mirror. So we are taking two rays, a ray which is parallel to principal axis, after refraction passes through focal point. Second ray which passes through optic center goes undeviated. Take these two rays backward, they meet somewhere here and the image is formed at capital D. M is equal to what? V by U. 1 by F is equal to 1 by V minus 1 by U. 1 by U is equal to 1 by V minus 1 by F. And M is equal to what? V into 1 by V minus 1 by F. V and V will get cancelled. And we have this thing 1 minus V by F. Or V, if V is equal to minus D, then M is equal to 1 plus D by F. Is that clear? Is it clear of you? Yes?
Yes.
Yes, sir.
Yes, sir.
Now I'm taking suppose example, suppose if F is equal to, I'm taking here example. If F is equal to what? 5 centimeter, what would be the value now? If F is equal to, this is 25 by 5, how much? If F is equal to 5 centimeter, this is 5, D is 25, keep that in mind, D is fixed value, 25 centimeters. So 25 by 5, how much? 25 by 5, how much? How much is 25 by 5?
5, sir.
5.
5 plus 1, how much? 25 by 5 is 5, 5 plus 1 is 6. So the magnification is 6 times. Means if the lens is of focal length 5 centimeter and the image is formed at D, then the magnification will be 6. Means it will be 6 times magnified. If you go to, maybe when you visited the bio lab, when you are doing the experiment, on the lens, you might have seen something like this, like this, into 10. Have you seen this one? Into 5 or into 10 or
Yes,
something?
sir.
This is 10 times it has magnified.
Yes, sir.
You can magnify the image 10 times, the object by 10 times. The image is 10 times the size of the object. Understood? Is that clear? That's
Yes, sir.
that is the meaning. Okay, chalo. We'll go to the second part now. In second part, we are placing. Now, what happens is when you weave this image in this way for a long time, there is a pain on the eye. So I'm working, especially the people who are working in the labs or the people who are working in astronomical laboratories or those who are working with doing research, especially with the lenses and all. So for them throughout the day they have to work and it will be very painful. So for that reason, you have to see that the image is formed at infinity. If the image is formed at infinity, then there is no pain on the eye. Such adjustment is known as normal adjustment. Such adjustment is known as normal adjustment. Is that clear? Such adjustment is known as normal adjustment. Normal adjustment means adjusting the object in such a way that the image is formed at infinity. I'll write the definition here. Adjusting the object in a way that, in such a way that the image is formed at infinity. Image is formed at infinity. So there is no pain on the eye. Now I'm drawing one more lens here. See here. Now here the object is at focal point now. Exactly at the focal point. What will happen now? There are two rays. A ray which passes through focal point. goes undeviated, the second ray, what happens? It goes like this. It goes like this. Okay. Now, H and this is small f. Is that clear? Now here, this is one is theta I. What is theta I? Angle subtended by the image. Theta I means angle subtended by image. How much angle it is subtended? And theta O is angle subtended by object. Okay, angle subtended by object. Now, for this previous diagram, I'm just taking once again. See, suppose this is the object. So sorry, this is H. This is H. This is D. Okay, this is D. Now what will happen now? D, and this is theta 0. This is theta 0. Okay. This is theta 0. Then what will happen here when we keep the eye here? Again, draw the eye. Don't forget to draw the eye. Okay. So the image is formed somewhere like this. This is theta O. What is theta O? Theta O means angle subtended by object, and theta I means angle subtended by the image. Okay. The second one. See once again from the beginning. See. Okay. Did I explain? Okay, this is done. Normal adjustment, adjusting the object in such a way that the image is formed at infinity is not a normal adjustment. Now I place the object at focal point. When I place the object at focal point, image is formed at infinity. So there are two angles, theta I and theta O. Theta I is angle subtended by image. Theta O is angle subtended by object. How this is the object? How much angle it is making with the object? Okay, object and image. So this is for object and this is for the image. So here H is the height of the object, D is the least distance of distinct vision. Understood now? Is that clear, all of you? Is that clear?
Yes, sir.
Okay, please copy this. So can I erase this now? Any doubt in this? Okay, can I erase this part, the left hand side? And do you have any doubt in this one? Is anyone having any doubt in this? Yes, madam. Any doubt in this? Huh? No, there is no theta 0. This is image, right? We are completely connecting to the image. For theta 0, I took from here. Okay. Done? Is it done? Yeah, can I raise now? Okay, so now here we have, I'm taking this theta 0 in the first diagram, that is for theta 0. I take tan theta 0. Tan theta 0 is equal to what? Opposite side to adjacent side. If theta is small, theta 0 is small, then what will happen? Tan theta 0 is equal to theta 0. Means what? Implies theta 0 is equal to what? H by 2. Theta 0 is H by 2. Now I'm going to the magnification formula. If you see the magnification formula, M is equal to H dash by H, which is equal to V by U. H dash by H, which is equal to V by U. Now, what is tan theta I now? So when I look at tan theta I, okay. Now erasing this part. See tan theta here. Tan theta I is equal to what? Which is equal to H dash by minus V. Okay. H dash by that is H dash by minus V. Height of the image by the value minus V. Okay, so we have that. We will simplify this one. When we simplify this, what do we get now here? We get H dash is equal to H into V by U. Now I'm going to substitute this value here. So tan theta I is equal to how much? Which is equal to H into V by minus V into U. This and this will go away. Implies tan theta I is equal to how much? Tan theta is equal to minus H by U. This is the value. We can also take theta I is equal to what? Minus H by U. Theta I is equal to minus H by U. Clear? So we got both the values. And also here U is equal to what? Minus F. In that case, theta I will be equal to minus H by F. Now angular magnification, you have angular magnification. Angular magnification means image angle subtended by image divided by angle subtended by object. Angle subtended by image is this value, and angle subtended by object is how much? Angle subtended by object is H by D. Okay, so what will happen? This and this will go away. Then what we are remaining? M is equal to what? Minus D by F. So this is the formula. Means what? But when do we use this formula? When the image is formed at infinity. When the image is formed at infinity, just take D by F. Okay, this minus of minus here, minus H by U, and theta 0 is again. So minus H by F. No? 1 second. So minus F, right? So minus and minus will go away. This will go away. So it is D by F. Okay. See once again from the beginning. Now tan theta 0, according from this diagram, we got tan theta 0 is equal to H by D. If theta is very small, we take tan theta is equal to theta. Tan theta is equal to, we take theta 0. Now, so theta 0 is equal to what? H by theta 0 is equal to H by D. Magnification is H dash by H, which is equal to V by U, and H dash is equal to H into V by U. And tan theta is equal to what? H dash by minus V. So we just what I'm doing now, I substitute this value, substitute here. V and V will go away. Formula minus H by U. So theta is minus H by U, and theta is equal to minus of minus will get cancelled and become plus. So magnification is upper, that is image by object. Substitute will get M equal to D by U. Is that clear all of you? Is this clear all of you?
Yes, sir.
Okay. Yes, please copy this one. Then we will go to the compound microscope, which is one of the important again. Yeah. Finish? Can I go ahead now?
Yes, sir.
Now, going to compound microscope, done, sir? Yes, Ahmad, are you understanding?
Yes, sir.
Okay. Any doubt? If any point you don't understand, please stop me and ask me. Okay. Now,
Yes, yes.
here we have now. So here this is objective. This is objective and this one is eyepiece. Objective and eyepiece. Now what happens? This is the object. We are taking two rays, a ray which is parallel to principal axis. After refraction passes through focal point. Second ray which passes through optic center. Sorry, I'll just do this. A ray which passes through optic center goes undeviated and the image is formed. There are two lenses here, they are coaxially mounted. The lens which is towards object is objective, and the lens which is towards eye is known as eye lens. Now, so these two rays, a ray which is parallel to principal axis passes through focal point, passes through the lens, and after refraction passes through the focal point. A ray which is parallel to principal axis. Second ray, a ray which passes through optic center goes undeviated. Now what happens here? We are taking two rays, one here, one in this way. So what will happen now? This ray will go in this way, and the second goes here. Now, so here what will happen now? Image is here, image is formed here. Okay, this is what? This is AB, and height is H. Okay, and this is the object distance which is 0. And what is FO? Focal length of the object.